Hi there, I'm going to help you go over this worksheet if you need any help. On number one, we're trying to figure out the rate law, and it gave me the basic equation, which is right up here. So I've got my three parts to look at. So the first I'm going to look at is the BRO3. When I look at BRO3, I want to be able to make it double or do something like that. If I look here, it'll double, going from point 1 to point 2. And that's great because these other ones will stay the same. In order to look at rate laws, I've got to make sure one of them changes, like my first one doubling, and the other ones have to stay the same. Then I can look at what happens to the rate when I do that. When I look here, it goes from that 8, 10 to the negative 4 to the 16, 10 to the negative 3. I can see that that also doubles. So then I ask myself, okay, then 2 to the what equals 2? And that's how I know that question mark is going to be equal to 1. This is a first order according to BRO3. Now I'm going to tackle my next one, my BR part. Again, I want everything to stay the same, but that one to double. If I look at the next line down, this one doubles, and these ones stay the same. So then I can look at my rate over here and see it goes from that 16 to 32. I can see that also doubles. So then I know, again, 2 to the what equals 2. It's the first order again. Then the last part I'm looking at is just my H. So once again, I've got to look at it, see when it doubles. This last part it doubles, but the other ones do not. So I'm going to try to find a different spot where they could stay the same. So look from here on down, that doubles. My BRs stay the same. Oh, but my BRO3s do not. I look from the top to the bottom. That doubles. This one stays the same, and this one stays the same. So that's where I want to look. I go from the top to the bottom, and it doubles. So then I look at my rate over here. I go from the top to the bottom, and it doesn't just double. I'd say it does more than that. So I'm saying to myself, 2 to the what equals 8 to the 32? That's to the 4 here. It's like quadrupling. 8 to 32 is a quadruple. So then I ask myself, 2 to the what equals 4? Well, that question mark's got to equal 2 then. This is a second order here for my H. All right, taking a look at my next problem here. I'm doing the same type of stuff. I'll start by looking at my I first. So I got to keep things the same. That first lane is keeping things the same, so that's great. I go from that 0.013 to 0.026, that's doubling it. So if I look at my rate over here, that's also a doubling. I'm thinking 9 to 18, that's a double. So again, 2 to the what equals 2. That's the first order again. Now I'm going to look for my OCL. That's my middle column. I want to look where it doubles or does something but keeps the others the same. Okay, I'm seeing right here. This one stays the same, this one changes, and this one stays the same. 6 to 18, that's like tripling it. So then if I look here, 4 to 14, that's like tripling it also. You can bust out your calculator. You're welcome to do that if you want to take this 14 divided by 4.7. I know that this has this 10 to the negative 3 stuff, and you could type it in as 10 to the negative 3, and that also come out the same, too, times 3. When I look at these problems, I'm kind of simplifying it down and just having these cancel out when I do the dividing. So I'm just thinking 14 divided by 4.7. I'm thinking to myself, yeah, that's about 3, if not 3. So if I triple it, and it triples the rate, then this is, again, a first order reaction. Going to my last one. I got my OH. I'm going to try to find a spot where it's kind of the same. All right, I'm looking down here. When I look at this one, it's the same for those ones, but down here, 5 to 20. 5 to 0.2, that means it goes quadruple. 18 to 4.7, that 18 to 4.7 sort of thing. So I'm thinking I might need to bust out my calculator for this one, but it's close to, in my head, if I want to do it in my head, I'm seeing that 18.7 is kind of close to 20. My 4.7 is kind of close to 5. So in my head, I can do 20 to 5, and I know that's a 4 difference. So a times 4 difference. If you want to bust out your calculator, what you'd want to do is you'd want to take that 18.7 divided by 4.7, and you would see that it actually reduces by 4. So it's 4 times slower. What you'd see in your calculator is it would probably come out as 0.25 because it'd be 1 over 4. That's what you'd see in your calculator. Now let's take a closer look at this. I went from 0.05 to 0.2. I quadrupled it, and it went 4 times slower. So I'm saying to myself, yeah, 4 to the what equals 1/4. Well, in my head, that says a -1. If it does the exact opposite, that means you're getting the inverse of it. And the inverse of it would be a power to the -1. This is OH to the -1. I know you might be thinking, like, how can I quadruple it and actually makes it slower? We're going to be talking about that during mechanisms, and so that's not quite our topic yet. So you'll just have to trust me and wait for it. Let's do this last part. Okay. It starts out pretty good, but then it gets a little bit tricky. You try and find a spot where it's kind of the same. In order to do it for A, I have to go all the way down this way. There's my A spot. So I'm going to be thinking about going upward. So 1 to 2, I'm timesing by 2, and all the rest stay the same. So 1 to 2 here, or, yep, 1 to 2. So I am doubling the concentration, but my rate is going much faster than that. My rate is going 3 times faster. Because I'm thinking to myself, 2 to the what equals, well, I want to do 4 divided by 0.5, so 8. So 2 to the 3, so this 8, this question mark is worth a 3. So if I'm doing my rate law expression, I'm doing rate equals K, A to the third. Alright, going for my B. If I can find a spot where they're the same. I got my here. If I look at this red spot, I can see that my A's are staying the same as some of my C's, but my B went from 8 to 16, so it doubled. If I look at my rate, it went from 32 to 32, so it did nothing. So here's where I'm saying to myself, 2 to the what equals, well, 1, because it did nothing for rate. If I took 32 divided by 32, I would get 1. So 2 to the 0. This is a 0 order 1. That means you can put in as much B as you want. It's not going to change the rate of reaction at all. So that brings me to C. And if you start looking for things with C, you'll see that it doesn't look good at all. But we know that B doesn't change. No matter what I do to B, the rate of reaction will never change anything. So that means I actually can not even look at B. It doesn't matter what it does because it doesn't change the rate of reaction. So here, all I need to do is find a part where C changes, but A stays the same. That makes things a lot easier. So I'm going to look right in here. I can see my C will double. My A stays the same. I don't care what B does because it doesn't change anything. And then my rate, well, it looks like when I double the rate, it halves it. In other words, it makes it go slower. So I'm saying to myself, this has got to be, if it's going slower, -1. If I double it and it goes 2 times slower, that's got to be a -1 for the rate law. So yeah, that B part is what makes it tricky, but now that you know that trick, I think you'll be fine next time. What you could do, even if this B happened to be a 1 or something, you can look at the rate law and just say to yourself, okay, I already know B is doubling, so that'll double the rate, and then how much more did it do it when you look at C? It makes it a little bit trickier, but it's totally possible. So part B, order the overall reaction. That means when I look at it, A is worth 3, B is 0, and C is what? -1. So I'm doing 3 plus 0 minus 1. This is an overall second order. The value of the rate constant. Here's where I want to just pick anything, any lane, and solve for it. In other words, I'll just take lane 1 here. My rate is 4.0 molarity squared per hour equals K, that's what I'm going to solve for. My A is 2 to the third. My B is 4 to the 0, so really that's 1. And my C is 2 to the -1. So this is when I'm kind of pumping my calculator here. Or I'm kind of thinking K, 2 to the third, -1, so this is really equal to K, 2 squared, and it's 4, so this is 4. So I'm looking at my k is really just equal to 1, right? I got to get my units, though. That's the tricky part. So I'm going to kind of take a little side step and get a look at my units. My units are m squared, or molarity squared, per hour, is equal to, here's my k, and then I've got molarity cubed. My b is molarity to 0, so I'm just going to negate it. Molarity to negative 1. So now I've got molarity squared over r, hours, and the k part here has molarity squared, molarity to negative 1, molarity squared. So I'm going to divide both sides by molarity squared, and those cancel. And I'm left with just this per hour. So the units of k is going to be hours to negative 1, or 1 over hours, however you want to go. I'm saying hours to negative 1. So in other words, I just looked at my units and saw how it all canceled out. And I got one last part here, my d. Kind of running out of space. The initial rate based on the following, I'm trying to find it. So in other words, I'm just going to kind of plug in. I'm going to say rate equals, here's my k, which is 1. It gave me my a as 1.5, and it's cubed. My b, 3.75 to the 0. In other words, that doesn't really matter because it's just equal to 1. And my c, 2.0 to the negative 1. I'm just going to push buttons in my calculator to find the rate. I'm not going to do it in my head. You probably won't either. I got 1.1 molarity squared per hour. Now I can look at units and kind of solve it out. I'm doing a cheater method and looking at the rate over here, and it gave me in units of molarity squared per hour, so I just put it right there. Because really what it's asking for is, what if I do a lane 8? And for A, I had this 1.5, and B, I had this 3.75, and C, I had this 3.0. Then what would this spot right over here be for the initial rate? And I just did that by pushing into my rate law. Now that I know. That helped.